Welcome to 2.1. And so our first 5 questions are dealing with average rate of change on a given interval. So if we recall correctly, we know that our average rate of change formula is f of b minus f of a over b minus a. So in every single one of these problems, we're given an interval and we're given functions. So we want to find the function values at those points and then divide by those said points. So, number one, we have f of x equals x squared minus 2. And then we have negative 1 to 3. Now, you want to always set up your equation so that you don't mess up, make a silly mistake. It's negative 1. Right, we plug in our a and our b, so f of b, f of 3 minus f of a, negative 1, over 3 minus negative 1. Now, whoops, that is a very crooked line. I apologize. So we have this bottom, which 3 minus negative 1 is 3 plus 1 is 4. And we want to find our function values, which is something that we should be able to do in our heads in this problem right here. F of 3. 3 squared minus 2 is 7. 7 minus f of negative 1. Negative 1 squared is 1 minus 2 is negative 1. So 7 minus negative 1 is 7 plus 1, which is 8 over 4, which gives us 2. Nice. Next problem. We have our 4 is b, 2 is a. And so a of 4 minus a of 2 over 4 minus 2. It's going to give us our average rate of change in the interval. You know that 4 minus 2 is 2. Just ignore that little dot there. A of 4, how do we get a of 4? We plug in 4 into our function. 2 to the 4th is 2, 4, 8, 16. 16. 2 squared is 4. 16 minus 4 is 12, divided by 2 gives us 6. Now remember, it tells us to use units if necessary, and we are giving units in this situation. So, $6 per year, right? Y is our dollars, X is our years. So, $6 per year is your average rate of change. Okay, number 3. We have a question that can be a little tricky if you don't know your unit circle, but hopefully we do. But just in case you don't remember a unit circle, I am going to draw one for you. A very small one. And all we need to know is that's 0. And this is pi over 2. This is pi. 3 pi over 2. And then back to 0 is 2 pi. Where's pi over 4? Pi over 4 is in the first quadrant between 0 and pi over 2. Right in the middle. Where's 3 pi over 4? That's between pi and 3 pi over 2. Sorry. That is between pi over 2 and pi. It's going to be right here. So we're looking for tangent value right here at pi over 4 and right here at 3 pi over 4. So let's set our thing up. We have h of 3 pi over 4 minus h of pi over 4 over, it's 3 pi over 4 minus pi over 4, that's 2 pi over 4. And simplify that, you get pi over 2. So do some work up here. H of 3 pi over 4. So, remember that tangent is sine over cosine. So sine of 3 pi over 4, since it's up here in the positive y-axis, it's going to be positive. And pi over 4, sine of pi over 4 is square root of 2 over 2. Sorry. This should be, we're doing pi over 4 first. So yeah, it's square root of 2 over 2. And remember that, divide that by cosine of pi over 4, which is, again, square root of 2 over 2, which is equal to 1. So we have, I'm not working very wisely here, but I hope you guys are making sense of what I'm doing. So we find our f of a. Now we're going to find our f of b, which is h of 3 pi over 4. Our x is now negative, so we have the same values, but x, which is cosine, is negative. So you get negative 1. Negative 1 minus 1, which becomes negative 2. Negative 2. Negative 2 divided by pi over 2. Well, you do key change flip, and you get negative 4 over pi. Hair per month. We have that unit there, right? Okay. ln x is our function from 2 to 7. And I'm going to start trying to cut down on the work so we can save some space and just overall make this faster. So we know b minus a is 5, right? 7 minus 2 is 5. Now, we don't know what ln 7 is. We don't know the exact value of ln of 2 either. So what we can do is have ln of 7 over 2 over 5. Why did I combine ln of 7 over 2? If you remember your logarithmic properties, we know that subtracting any logarithmic function is the same thing as dividing. So 7 minus 2 would be 7 over 2. And you can rewrite this as 1/5 ln 7 over 2. Alright, and then the last one is a cosine x question. So again, it's pretty straightforward. We have f of 0 minus f of negative 1. 0 minus negative 1 is 1. Cosine of 0, you have to know your trig. Cosine of 0 is just 1. What's cosine of negative 1? Well, we actually don't know that. So we're going to leave that there. All over 1, which is the same thing as 1 minus cosine of negative 1. And there we go. That is the first 5 questions. I was looking at the answer key on Flip Math, and they have questions 4 and 5 as decimals. That's perfectly fine, but it didn't tell us to use a calculator. So these answers right here, they are perfectly fine, okay? Unless you're given a calculator, then you can actually plug them in. Okay. Again, I want to reiterate that the average rate of change formula is f of b minus f of a over b minus a. It's really important that you remember this, okay? Now we're given a table here, so we actually don't have to solve for anything, right? We don't have a function. We have the function value and your x or t in this case. Okay, f of 13, or I should say s of 13, is given as 10. So 10 minus s of 3, which is 4. Then 13 minus 3. Hopefully this makes sense, right? F of b minus f of a over b minus a. And we get 6 over 10. You can reduce that if you want. I'm not going to. You should reduce it. Here we go. Next question. S of 12 given as 5. S of 0, negative 2 over 12 minus 0. And that is 7 over 12. Okay, and then last one we have S of 4, negative 7 minus S of 3, which is 4 over 4 minus 3, negative 11. Alright, and then hopefully that makes sense. It actually doesn't tell us to put the units, but you should get into the habit of putting the units just because you will get points taken off most of the time if you don't. And so yeah, these are our answers. Alright, now we have a different kind of average rate of change question. We have a graph and we have same thing here, the intervals. So all we gotta look is the graph at these points. What is their value, the function value? So negative 2, we have, sorry, no, that's not right. Negative 2, we have negative 1, it looks like. So negative 1 minus function value negative 5 right here, which is 2. Negative 2 minus negative 5. Negative 3 over 3 equals negative 1. That one is pretty straightforward. Okay, f of 5 is 5. Negative 1 is 2. And then 5 minus negative 1. 3 over, and then that's 5 minus negative 1. 5 plus 1 is 6. You can reduce that. And then the last one we have is negative 2, which we already knew was negative 1 from before, minus negative 4 right here. Our values, again, negative 1. So no matter what our denominator is, we're going to have a 0. 2 minus negative 4, 0 over 2. All right. So here it gets a little bit more involved, but again, the concept is the same. We are given the values on the graph, but now we have a little bit more work to do. So here, we actually want to set up these little information bits so that we don't get confused. Okay. So h of x is f of x plus g of x. So all we're looking is f of the value plus g of the value, and that's going to give us h of that value. So at 3, we have 0 and 4. 0 plus 4 is going to give us 4. Negative 4, we have negative 2. 2 gives us 0 when you add them. And so h of 3 minus h of negative 4. And 3 minus negative 4 is 4 over 7. Next question is, I think this is called a composite. I'm not sure. But anyway, we have to find the g, the value of g at that certain point. And then whatever we get there is what is our f. So let me break that down because I know I didn't read that too greatly. So again, we're gonna put, well, hold on. Okay, k of 0, k of -4. K of 0. K of 0 is f of g of 0. K of -4 is f of g of -4. Okay. K of 0. What is g of 0? G of 0 is the bottom graph. G of 0 is -1. So k of 0 is f of -1. K of -4 is f of -4. Oh, sorry, hold on. It's not right. Okay. G of -4. That's -2. And so k of -4 is f of -2. F is your top graph, so f of -1 is 3. F of -2 is also 3. So we know that our average rate of change is 0 because 3 minus 3 is going to give you 0. Now, hopefully that makes sense. I'm going to do a little bit of trimming here just because I want some space for that next question. All right. 14 is essentially the same thing as 13. We have g of f of x instead of f of g of x. So the problem solving is the same, right? We find our w of 3, w of -2, and then, I mean, the work should be very simple to understand. So I'm not gonna go over that. Just refer to question 13. Okay. 15, 16, 17. We're gonna find the instant rate of change at the given x value. So something that would be useful is to find our f of a. F of a is the function value at the given point. What's the given point? -1. So f of -1 is equal to 1. It's -1 is 2. So that's our f of a. We're going to plug in f of a plus h. We're going to plug in a plus h into every x that we see. So limit as h approaches 0 of a plus h squared minus a plus h, and then we have minus f of a, right, which is just going to be minus 2, right? And we already found our f of a. Minus 2 all over h. Right here, we gotta bring this down. We're going to expand. So a squared plus 2ah plus h squared minus a minus h minus 2. All right. So now we're going to plug in -1 into our a. Why? Well, we're finding the derivative at a. So our a is -1. So I'm going to erase right here. What's -1 squared? 1. This right here will become -2h. -1 is +1. And then all over h. Okay, 1 plus 1, 2. Minus 2 cancels out. So we're left with negative 2h minus h plus h squared over h. So that is negative 3h plus h squared over h. Factor this out, and we get negative 3 plus h, and h approaches 0, we get negative 3. Now, I apologize greatly. That explanation was not the best, but I hope you could follow along. I'll try to explain this next one better. All right. Next question. F of x equals square root of x. We have our point x equals 5. That is our a value. To find our f of a, we're going to do f of negative 5. All right? That is our f of a. So, f of 5, simply square root of 5. Okay. So all we have to do here is write our limit. Oh, it's not writing. Okay, there we go. Square root of f of a. Our a is 5 plus h minus f of a, which it's right here, square root of 5 over h. Now, if this looks familiar, well, it is. We have to conjugate this. So, again, hopefully you recall that the conjugate is just the opposite sign of the square root. And we do, again, same thing, the denominator plus square root of 5. Okay. Now, this and this cancel out, and then this and this cancel out. So, we get limit as h approaches 0 of 5 plus h, then minus 5 over square root of 5 plus h plus square root of 5. Okay. Okay, sorry, I had to get rid of that thing. Okay, 5 and 5 cancel out, so we're left with limit as h approaches 0 of h over. And then look at this. Sorry, I forgot to bring that down. So we have h over h, 5 plus h plus square root of 5. Very sloppy, I know, but we're left over with 1 over square root of 5 plus h plus square root of 5. H is 0, and then ultimately you get 1 over 2 square root of 5. Again, I apologize. I am trying to navigate through this. It's my first time doing this. This pen, this computer is like weird. So anyway, I'll be right back. I'm gonna erase this. Okay. Next problem. 1 over x. 1 over x, and our instant rate of change is at 2. So f of 2 is 1 over 2. Alright. Let's get it. Limit as h approaches 0 of f of this a plus h, right? And then minus what we figured out here, 1/2 right here, over h. Now, we're going to have to rationalize this, which could be annoying, but I'm not going to go into too much detail. You should see that the LCD, least common denominator, is 2 times 2 plus h, which we're going to do here, 2 times 2 plus h. That gets rid of that. That gives us a 2 here, and that gives us a 2 plus h here. And then an LCD. Limit as h approaches 0, 2 minus 2 minus h over and then 2 over 2 plus h over h. So negative h over 2 times 2 plus h over h. And then now we're going to rewrite this because this is a little bit of a annoying thing to look at. So 2 plus h times 1 over h. Now we can do that. Cancel that out. Negative 1 over 4 plus 2h. H is 0, as we all know. That gives us our answer of negative 1 over 4. Alright. I'll be back after I erase this. Alright. Questions 18 through 20. Now we're using a different form, but we're still trying to find the instant rate of change. So notice the form is now limit as x approaches a of f of x minus f of a over x minus a. So first we kind of want to do this similar. Oh my goodness. We want to find our f of a. Alright, perfect. So our first question is at x equals negative 3. What's f of negative 3? Negative 3 squared is 9 times 2 is 18 plus 3 times negative 3 is negative 9. 18 minus 9 is 9. Minus 4 gives you 5. Okay. So we first start with our f of x. So simply that is given is 4 minus f of a. Okay. We found our f of a over x minus a, which is x minus negative 3, just that. Now, I should have written limit. Don't forget to do that on your paper. But I should have done limit as x approaches negative 3. Anyhow, I'm going to continue here. Now, what is negative 4 minus 5? Negative 4 minus 5 becomes negative 9. Okay? Becomes negative 9. What can I do here? Well, the only thing that seems logical to me is to factor. Minus, should be 18, doing 8 times c here, and then x minus x plus 6 times x minus 3, and x plus 3. Sorry, I'm making mistakes here that I should not be making. Divide this by 2, right? since we did multiply -9 by 2. So 2x minus 3 over x plus 3. That cancels. That cancels. And so we have 2. And then remember, as x approaches -3, 2 times -3 minus 3. That is nothing but -9. Alright. Next problem. F of x equals square root of 3x at x equals 7. So we're going to find our f of a, f of 7. If the pen wants to work, there we go. Okay. F of 7, which is square root of 21. So, limit as x approaches 7 is equal to f of x minus f of a, which we found out is square root of 21, minus x, oh my gosh, over x minus a. Alright, again, we have a square root problem, so we want to conjugate 3x. And since there was a minus, now we do plus square root of 21. Do the same thing to the denominator. Square roots cancel out. We're now with 3x minus 21 over x minus 7. And then square root of 3x plus square root of 21. Notice that this can be factored out. It's a 3, by the way. X minus 7. 3x plus square root of 21. So we get left with, I'm jumping around here, but you guys can write smarter than me, so square root of 3x plus square root of 21. Okay. And then now what we can do is plug in our 7, 3 over square root of 7 times 3 plus square root of 21. Square root of 7 times 3 is square root of 21. So we get 3 over 2 times square root of 21. Hopefully that makes sense. Okay, last question is f of x equals 1 over 5x at x equals -2. F of -2, 1 over -10. So -1 over 10 is our f of a. Limit as x approaches -2 of f of x minus f of a over x plus 2. Okay. I realized I probably should have shifted this to the left. Anywho, what we do here is we're gonna find the LCD. So LCD of 5x and 10 is just simply gonna be 10x. So to get from 5x to 10x, you are gonna multiply by 2x. So 2x over 10x. And then to get from 1 to 1 to x, you're gonna multiply it by x. And again, the LCD is just simply gonna be 10x, right? Okay, so we have 2, sorry, messed up when I put that there. So it should be 2 plus x over 10x. Now, we want to multiply this by 1 over x plus 2, right? To make this simpler, we get 1 over 10x. X is -2, so we get 1 over -20. And there we go. We have something that's a bit easier. So we're going to be identifying the instant rate of change of a function and then the original function, as well as the x value. Okay, so the key here in these types of questions is identifying what the limit approaches, and that's going to tell you a lot. Now, the easiest ones are when the limit is as x approaches, right? Because then again, you have this formula, right? You have two formulas. We have f of x minus f of a over x minus a, limit approaches a, and we have limit as h approaches 0 of f of x plus h minus f of x over h. Now, this one right here is going to be very simple. This one might be a little tricky at first, but I will help you to understand how to find your solution. Okay, x approaches 7. We know that this one on the left is going to be our form. So our first one right here should be our function f of x. So function f of x is 1 over square root of 2 minus x. That is very sloppy, I know. It is what it is. And then our instant rate is just what x approaches. So x approaches 7. Our instant rate is at x equals 7. Again, number 22, x approaches something. So we know that's going to be in the form of f of x minus f of a. So we have our f of x right here, 3x minus 9x squared. And again, our instant rate is whatever value x is approaching. For this one, the h ones, it's a little bit, weirder, but it's still not too bad. Okay? Remember, now we're dealing with f of x plus h. So we're looking at this. This is going to be our f of x plus h. Well, we see a 3 in both of these, so that's not going to change. We also see an ln. That's not going to change. And so we have a 2 on both. That 2 is going to be our x. And then our function is going to be 3 ln x. Simple as that, right? Because think about it. You have our f of x plus h minus f of x. Although actually this one might be... Okay, anyway. Just ignore that. And yeah, like this still makes sense, right? We have 3 ln of the inside minus 3 ln 2. F of x plus h minus f of x. So hopefully, if you can see it, that makes sense. I think it'll be easy as well to understand number 24. What I like to think about is you have h plus something or h minus something. Think of that as your x. So 3x squared minus 7x plus 1. And then this right here is your value. So that is x equals 3. Sorry, that is not the value. Hold on. The value is 1. your value should be this right here. The the constant inside your parentheses. I apologize for that. Okay. Now, this one definitely seems a bit, complicated, but again, you're identifying your form. X approaches pi over 2. So, again, we're dealing with f of x minus f of a. F of x is right here. That's all it is. 6x squared sine x. And then your instant rate occurs at x approaches pi over 2. This one can also definitely seem intimidating, but again, what I said before, I'd like to think as your h plus or h minus as your x. Log stays the same. 2 minus 4x, right? That h minus 5, that is your x. So log of 2 minus 4x is your function. And again, your instant rate of change is that constant with next to your h, negative 5. Whoops, I keep making that mistake of drawing stuff. Okay. 27. Form, you tell me. Right, f of x. That is your indicator that this is your f of x. And again, x approaches 5, so that is your instant rate. Here, again, it's the same thing, right? You have your h plus or h minus something. That is your x. E to the 6x, don't forget the 1, plus 1. And this right here, that is going to be your instant rate. That is where your instant rate occurs. So again, you notice for your h problems, you look for h minus h plus something. You make those your x's and you keep the original function, right? Log of 2 minus 4x, 3 ln x, and then your instant rates are those constants next to the x, next to the h, sorry. So I hope that makes sense. Next problem, number 29. Let f be the function defined by f of x equals ln 7x. The average rate of change of f over the interval 2, a is 41, where a is greater than 2. Which of the following is an equation that could be used to find the value of a? Okay, value of a. All right, average rate of change. We're given very useful information here. Well, I don't see any ln's, so I don't think this piece is important right now. We are given that the average rate of change is 41 in the interval 2a. So remember that basic formula and you'll be successful. F of b minus f of a over b minus a. Okay, this is our b, this is our a. Let's plug it in. F of b, oh, sorry, hold on. Now, it's a little like confusing because our a is our b and then 2 is our a. But f of a minus f of 2 over b minus a. So a minus 2. Well, at first, I don't see anyone that gives us this. However, this one looks pretty close. And we do know that this is equal to 41. And that is given here, right? The average rate from 2 to A is 41. And so C would be your correct answer here. That wasn't too bad. All right. Average rate of change of f of x equals sine x ln x. Okay. let's find our f of a, which is our f of b, but it's pretty funny. Okay, f of a, we don't have any values, so we're just going to plug in that variable. F of x, f of 1, sine 1, ln 1. Oh, ln 1 is 0, you should know that. And so f of b, which is really f of a, minus f of a, which is f of 1, over a minus 1. And that is going to be our final answer. Okay. I'm going to need a calculator for this one, so take them out or just go on the website I'm about to show you. So if you search up Minnesota TI-84, and then we go to grades 8 through 11 calculators, we can find this wonderful TI-84 right here. Alright. Okay. Yes, I know my battery's low. Okay. Today's school lunch was inappropriately thrown over the school fence by Mr. Kelly. For 0 to 90, the amount of food remaining, assuming no animals eat it, is modeled by f of t is equal to whatever that is, where f of t is measured in grams and t is measured in days. Find the average rate of change of f of t over the interval 0 to t to 90. All right. Nothing complicated here. We are just finding the average rate of change from 0 to 90. So 544. I want to do this. Well, that's annoying. Okay. 544. Is it 0.311? Yeah. 0.97. 907 to the x. Okay. Now that we have that, we can quickly solve for this. We go to variables, y variables, y1 90 minus y1 0, and boom, this is our answer. This is the average rate of change. So we can truncate it, we can round it. I've written negative 6.046. That's what I'm gonna go with. Negative 0.40. Sorry, 0.4. Let me just erase that. 6. Oh my goodness. Okay, and then we have units. We have grams per day. All right. And finally, our last question is a continuous function f is shown above and defined on the closed interval -5 to 4. For how many values of b is the average from how many values of b from -5 less than b less than 4 is the average rate of change of f on the interval b to 1 equal to 0. All right. So where do we start here? Well, average rate of change equals 0. So that means that our y values are the same, right? In 2 points, our y values are going to be the same. Okay. Alright, so we're given this range b to 1. So we can cut off anything that happens here. This is our endpoint from b to 1. Now, since 1 is one of the endpoints, we're going to draw a straight line. Draw a straight line because our average rate of change is equal to 0. Okay? Now, I'm going to erase this stuff over here just because that was to show that that doesn't matter. What really does matter is these points right here. All of these points are where your average rate of change is going to be equal to 0. And so we're going to have 2 points where the average rate of change of f is equal to 0. 2 values, that is, this value, right, and this value. So we're going to have f of negative 1 point something, f of negative 4 point something, and then f of negative 1, and then 1. Okay? So that sums up 2.1. I hope this could be insightful. Any questions, please let me know. And I'll try to be more efficient and have better explanations for you next time around. Thank you for watching.